Hi everyone, Peter here from Flow High Performance, and in this video we'll be covering how to implement reactive methods of programming for strength training. First and foremost, we need to establish what we mean by reactive programming. A reactive programming approach is when a program is written based on how an athlete is adapting to training in the short term. This means that the program is not planned out in detail from a long-term perspective. The term reactive refers to the fact that programming is determined in response to training rather than being written proactively. So why should a coach or athlete use reactive programming strategies? Using reactive programming is generally a more effective method of programming for most intermediate and advanced strength trainees. This is because it uses individual feedback to progress at an individual rate. This is important because a standard program assumes that we can predict how an individual will respond to a certain training stimulus. However, it is almost impossible to predict the exact magnitude or rate of progression that an athlete will see from a certain program. Also, an individual's response to training will change over time based on their level of advancement and external stresses at different times of their life. Not all programs need to be completely reactive in nature, but most programs can benefit from some form of individual auto-regulation. Let's now cover what programming methods we can use to implement a reactive approach to programming for strength training. Before getting into the programming details, we need to understand that the term reactive programming is not a rigid system that follows specific rules. It simply means that training is somewhat regulated by an individual's adaptation to training. Therefore, the following methods that we will cover are general ideas that can help a coach or athlete individualize programming. The first reactive programming strategy that we can implement is to determine the mesocycle duration and when a deload is required. In a typical programming sense, a block or mesocycle of training is planned using 3 to 5 weeks of overloading training, followed by a deload week. This is a fine method to use, although it may be more accurate to implement a reactive deload rather than a proactive deload. So a trainee may continue training until performance plateaus or declines, and then a deload is implemented. This may be only 3 weeks of training for one trainee, and it may be 6 weeks of training for another trainee. Furthermore, the number of weeks a trainee can train before a deload is required may change over time. For example, let's use a back squat to determine when a deload is required. In this example, the trainee aims to perform the back squat for 3 sets at a load of 100 kilos with an RPE of 8 for each set. The first week they perform 7 reps in the first set, 6 reps in the second set, and 4 reps in the third set. In the second week, they may perform 8 reps in the first set, 6 in the second, and 5 in the third. So on average, the reps are higher because the trainee is getting stronger. In the third week, they may perform 9 reps in the first set, 8 in the second, and 7 in the third. In the fourth week, they may perform 10, 8, 7 reps respectively. And in the fifth week, they may perform 10, 8, 7 reps again and fail to improve upon the previous week. So the trainee may now want to implement a deload after this fifth week because performance has plateaued. Another method of reactive programming that can be applied is via the use of tracking bar velocity. During strength training, velocity has an inverse relationship with load lifted. This means that the heavier the load is, the slower the velocity will be, whereas the lighter the load is, the faster the velocity will be. Tracking bar velocity can be used to determine what loads will be lifted on that particular day. This can be done by lifting a submaximal load as fast as possible to determine if the trainee is in a good or poor condition on that given day. If the velocity is faster than average, then a heavier load may be used. If the velocity is lower than average, then a lighter load may be used. For example, on a heavy squat session, the trainee may work up to 85% of their 1RM and track the velocity of this rep. If the velocity is much faster than average, the trainee may be in good condition on that day for whatever reason, and a new 1RM may be attempted. However, if this 85% moves very slowly, then they may leave the load at around 80% and cut the heavy lifting there. The last method of reactive programming is the use of reps in reserve. Reps in reserve, or RIR for short, is simply quantifying how many reps a trainee could have performed before failure in a given set. An RIR of 0 would mean that no more reps could have been performed, i.e. the trainee reached complete failure. An RIR of 1 means that 1 more rep could have been performed before failure, an RIR of 2 means that 2 more reps could have been performed before failure, and so on. The reps in reserve system can allow trainees to track progress even with submaximal efforts. This can constantly be used as a gauge of progress. This can be used for maximal strength lifts and also for hypertrophy training. For a strength training example, a trainee may work up to a back squat single at an RIR of 2. This means they could have performed 3 reps, but they only performed 1. This could be performed weekly as a measure of 1RM performance. If the trainee can use more weight with the same RIR level, then they are probably getting stronger. For hypertrophy training, RIR can be used to gauge progress too. The trainee can set specific RIR levels for a given exercise, and they can perform each set at this given RIR with the same load. If more reps are being performed at the same RIR, then progress is being made. For example, a trainee may perform 3 sets of a bench press with 80 kilos at an RIR of 2. The trainee may have performed 12 reps on the first set, 10 on the second set, and 8 on the third. In the next training session, the trainee may perform the same load on the bench press for 13, 11, and 8 reps respectively at the same RIR. This is a sign of progress since more reps have been performed with the same load and reps in reserve. Thanks for watching, and hopefully you got something out of this video. Remember to subscribe if you haven't already.